The topic is slope of a line. Objective 1 in this topic is find the slope of a line given 2 points on the line. And in order to find the slope of a line, we need the slope formula. So the slope is something we will call m, and we'll say that the line contains the points x1, y1, and x2, y2. So any 2 points on the line. M is the rise, how much up or down, over the run, how much left or right. How much up or down is the change in y, how much left or right is the change in x. And we get the change in y by doing y2 minus y1. Likewise, we get the change in x by x2 minus x1. And we have this statement that x2 is not equal to x1 because if they were the same, we would be dividing by 0, and dividing by 0 is undefined. Slope would be undefined in that case. So let's use this formula to find the slope of the line through 0, 3, and 2, 5. And then once we've found the slope, we're going to graph the line. So let's let our first point, x1, y1, be 0, 3. Let's let our second point, x2, y2, be 2, 5. And if x1, y1 is 0, 3, and x2, y2 is 2, 5, then y2 minus y1 would be 5 minus 3. x2 minus x1 would be 2 minus 0. That gives us 2 over 2, which is 1. We get a slope of positive 1. If we were to graph this line, we only need 2 points. So plot 0, 3, plot 2, 5, draw the line through the 2 points. Note that from left to right, this one goes upward. Positive slopes, like positive 1, will go upward from left to right. Let's find the slope of the line containing the points 4, negative 3, and 2, 2. So again, we'll let our point 1, our x1, y1, be 4, negative 3. We'll let our point 2, x2, y2, be 2, 2. Then in the formula, be very careful. Y2 is 2 minus y1 is negative 3. So minus a negative on the top. On the bottom, x2 is 2. x1 is 4, so 2 minus 4. 2 minus negative 3 is 2 plus 3, that's 5. 2 minus 4 is negative 2. We get a slope of negative 5 halves. Plot those 2 points, 4, negative 3, 2, 2. Draw the line through it. Notice that this one from left to right goes downward. Negative slopes, like negative 5 halves, go downward from left to right. Now, you might be thinking, what if I picked the other point? What if I let my x1, y1 be 2, 2, and I let my x2, y2 be 4, negative 3? That's okay. When finding slope, it makes no difference which point is identified as x1, y1, and which is identified as x2, y2. Just remember that whatever y value is first in the numerator, the corresponding x value must be first in the denominator. And one of the helpful things that I have heard in the past to help me remember that y's are on top and x's are on the bottom is to think of that formula like a picnic table. The X's on the bottom form the legs of the picnic table and it will be sturdy. But if you put the Y's on the bottom, it's just going to fall over. So you need your sturdy X's on the bottom. The second objective in this topic is finding slope given an equation. So we've had our standard form where the X and the Y are on the same side. We've kind of looked at this already. We haven't named it before. But when we have the equation solved for Y and it falls in the form Y equals mx plus b, we already know that b, the thing that's added or subtracted at the end, is the y-intercept. But m is the slope. The thing that's multiplied by x is the slope. So if we had y equals 3x minus 4, the slope would be 3 because that's what's multiplied by x. And the y-intercept would be 0, -4, since -4 is the thing that's on the end, the thing that's added or subtracted. That doesn't involve the x. So let's say we wanted to find the slope of the line -3x plus 2y equals 11. Well, we would solve the equation for y. We need to get the y by itself, which means we need to get the positive 2y by itself, which means we need to get rid of minus 3x. We get rid of minus 3x by adding 3x to both sides. That leaves us with 2y on the left and 3x plus 11, or 11 plus 3x on the right. Finally, to get the y by itself, divide both sides by 2, and we get 3/2 x plus 11/2. Everything just got divided by 2. 3x over 2, we kind of shove the x overboard and it floats off to the side of the fraction. But the thing that's multiplied by x is the slope. So the slope is 3/2. And it wasn't asked for, but the y-intercept would be 0, 11/2, because plus 11/2 is what's added off to the end. That doesn't involve the x. Next up, find the slope of the line -y equals 6x minus 7. Well, at first glance, you might think that this is already in slope-intercept form, so you might say that the slope is 6. But doing so would be incorrect. It would be missing the fact that this is not solved for y. This is solved for -y. So we need to solve the equation for y and not -y. Divide both sides by -1. That gives us y on the left, and it changes the sign of everything on the right. Instead of 6x minus 7, we get -6x plus 7. Now that it's solved for y and simplified, we see that the number we're multiplying by x is -6. That makes -6m. That makes -6 the slope. Objective 3 in this topic is interpreting slope-intercept form. The adult one-day pass price y for Disney World is given by y equals 3.53x plus 67.39, where x is the number of years since 2006. Use this equation to predict the ticket prices for 2026. Well, we're told that x is the number of years since 2006. In this case, 2026 would be 20 years since 2006. So x is 20. The price is y, so plug 20 in for x. And when we plug 20 in for x and simplify, taking 3.53 times 20 and then adding 67.39, we get 137.99. So the adult one-day pass price in the year 2026 can be predicted to be $137.99. The fourth objective in this topic is finding slopes of horizontal and vertical lines. Find the slope of the line x equals -2. Well, knowing that x equals -2, all of our solution points must have an x value of -2. So let's at random pick 2 points where x is -2. Maybe -2, 1. Maybe -2, 2. Maybe -2, 3. We're going to use -2, 6 and -2, 8. Where did the 6 and the 8 come from? We just picked them at random. They don't have to be 6 and 8. We just need 2 points to plug into the slope formula. And when we use these 2 points, the interesting thing is not what happens on the top when we subtract the y's. The interesting thing is what happens on the bottom when we subtract the x's. The x's are the same. Remember, we said that couldn't happen, because if it does happen, we have 0 on the bottom, and that makes the slope formula undefined. So we say that the line x equals -2, or any line that crosses the x-axis and doesn't have a y-intercept, in other words, any vertical line, has an undefined slope. So up and down, undefined. And again, why? Well, it's because for any 2 points, the x values will be equal to the same number. We'll subtract, we'll get 0 on the bottom of the slope formula, which makes it undefined. So up and down is an undefined line. Now let's find the slope of the line y equals 3. Well, again, knowing that y equals 3, all solutions must have a y value of 3. So let's pick any 2 points that have a y value of 3. Maybe 0, 3, maybe 1, 3, maybe 2, 3, maybe 3, 3. We're going to use 5, 3, and 7, 3. But we just pick those at random. They don't have to be 5 and 7. We just need 2 points where y equals 3 to plug into the slope formula. This time, the interesting thing is not what happens on the bottom, it's what happens on the top. y2 minus y1 is 3 minus 3. We get 0 on the top, and 0 on the top equals 0. We say that there is 0 slope for the line y equals 3. All horizontal lines, all lines that strike the y-axis but don't have an x-intercept, all horizontal lines have a slope of 0. So 0 slope is the flat line. Why? It's because any 2 y values we pick from a horizontal line will be the same. The top of the slope formula will equal 0. So the slope is 0. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So to review, up and down was undefined, flat was 0, increasing, going up from left to right, was positive, and decreasing, going down from left to right, was negative. Objective 5 in this topic is compare the slopes of parallel and perpendicular lines. Two lines that never intersect are called parallel lines. Parallel lines will have the same slope and different y-intercepts, unless, of course, they are vertical lines which have no slope. But even then, the slopes would both be undefined, so still kind of the same. Vertical lines are also parallel, though. So that's what two parallel lines look like. And previously we looked at f of x equals 2x and g of x equals 2x plus 1. The slopes of both of those were 2. And that's why they looked like parallel lines, where one line was just shifted up 1 unit. So parallel lines never intersect. They have the same slope. Perpendicular lines not only intersect, they intersect at right angles. Two non-vertical perpendicular lines have slopes that are negative reciprocals of each other, or opposite reciprocals. The product of their slopes will be -1. Any horizontal line paired with a vertical line are perpendicular to each other. They meet at right angles as well. So what does that look like? It looks like this. They cross at right angles. If one has a slope of A, the other one has a slope of -1 over A. Take the opposite sign and flip it. So parallel lines, same slope. Perpendicular lines, opposite reciprocal slopes. Keeping that in mind, we should be able to determine whether the line 6x plus 2y equals 9 is parallel to -3x minus y equals 3. If they're parallel, they would have the same slope. So we need to find the slope of each line, starting with 6x plus 2y equals 9. How do we find slope from an equation? We start solving it for y. So subtract the 6x from both sides. That moves the x's from the left to the right. Then divide both sides by 2, which divides everything by 2. Y equals -3x plus 9 halves. So the slope of the first line is -3. Y equals mx plus b. M is -3 here. Now let's look at the second line, -3x minus y equals 3. Again, we want to solve it for y, so add 3x to both sides, and then take the opposite of both sides, divide both sides by -1. We get y equals -3x minus 3. This one also has a slope of -3. Since the slopes are the same, they are parallel lines. If we were to graph both of these, they would both have the slope of -3. One would cross the y-axis at +9 halves. The other would cross the y-axis at -3, but they would never intersect each other. We also have enough information to be able to determine whether the line x plus 3y equals negative 15 is perpendicular to negative 3x plus y equals negative 1. If they have opposite reciprocal slopes, then they're perpendicular. So once again, we want to find the slope of each line. Starting with the first equation, x plus 3y equals negative 15. We want to solve this for y. Subtract x from both sides, negative x minus 15. Divide both sides by 3, negative 1/3 x minus 5. The slope of this line is negative 1/3. So we would need an opposite reciprocal to be perpendicular. Instead of negative, it would have to be positive. Instead of 1/3, it would have to be 3/1 or 3. So we're looking for a slope of positive 3. We have negative 3x plus y equals negative 1. We're going to add 3x to both sides. That gives us 3x minus 1. That's in y, I should say slope-intercept form. M is 3. Just like we wanted, these are perpendicular. So let's determine whether the following lines are parallel, perpendicular, or neither. The first line is negative 5x plus y equals negative 6. The second line is x plus 5y equals 5. So solving the first one for y, we're going to add 5x to both sides, and we get y equals 5x minus 6. Solving the second one for y, we're going to divide both sides by 5. That divides everything by 5. Y equals negative 1/5 x plus 1. They're not the same, so they're not parallel. They are opposites. One's positive, one's negative. They are reciprocals. One's 5, one's 1/5. So these are perpendicular lines. And that is it for this topic. The topic is equations of lines. The first objective in this topic, graphing a line using its slope and y-intercept. So let's graph 2/3 x plus 1. From this form, from this y equals mx plus b form, we know that the slope m is 2/3, and we know that the y-intercept is 1 for the point 0, 1. So let's start by plotting the point we know. We know the y-intercept. So plot that point at 1. Now, remember when we first talked about the slope formula, it wasn't just given y2 minus y1 over x2 minus x1. There was all that stuff in front of it. One of those things was change in y over change in x, and we got that from rise over run. Slope is rise over run. The top tells us the rise, how much we go up or down. The bottom tells us the run, how much we go left or right. Positive is up or right. Negative is down or left. So this slope of 2/3 tells us that from any point to any other point, we would go rise 2, run 3. In other words, up 2, right 3. So let's go from the y-intercept point. Up 2, right 3. That's the point 3, 3. And once we have a second point, we can draw our line through the 2 points. So we didn't have to make an XY table in order to graph because we knew the y-intercept and we knew the slope. The y-intercept gave us a starting point, and the slope gave us the rules on how to find another point. Now, we also could have gone down and left, because -2 over -3 is the same as 2/3. So instead of up and right, we could have gone down and left and got the point. It looks like -3, -1. But that point also would have given us the same line. Let's graph 3x plus y equals -2. Well, we need to solve it for y first so that we can see the slope and the y-intercept. So we take our equation and we subtract 3y from both sides. Sorry, 3x from both sides. That gives us y equals -2 minus 3x, or -3x minus 2. The y-intercept is -2. The slope is -3. So take our y-intercept and plot it. -2 on the y-axis. And then -3 as a fraction would be -3 over 1. -3 on top means down 3. +1 on the bottom means right 1. Down 3 and right 1 from this point would be the point 1, -5. And once we have our second point, we can draw the line through the 2 points. And once again, -3 isn't just -3 over +1, it's also +3 over -1. So we could have gone up 3, left 1, which would have put a point here at -1, 1. Objective 2 in this topic: using slope-intercept form to write equations of lines. Let's write an equation of the line with y-intercept 0, -5, and slope of 2/3. Well, all we know is y equals mx plus b. So let's start by writing that down. Y equals mx plus b. We are given the slope of 2/3. We are given a y-intercept of -5. So 2/3 is m, -5 is b, and when we simplify, we get y equals 2/3 x minus 5. Objective 3 in this topic: using point-slope form to write the equation of lines. So what is point-slope form? Point-slope form is y minus y1 equals m times the quantity x minus x1, where m, as always, is the slope, and this time we have a point in the equation, x1, y1. So y minus y1 equals m times the quantity x minus x1. This is useful in cases like this where we're given a slope and we're given a point that the line passes through. Even though it says to write the equation in slope-intercept form, y equals mx plus b, we can still start with this new point-slope form. So y minus y1, y minus -12, equals m, -2, times the quantity x minus x1, x minus -11. Simplify, our minus and negative becomes plus, our minus and negative becomes plus. We get y plus 12 equals negative 2 times the quantity x plus 11, and then negative 2 distributed through gives us negative 2x minus 22. Negative 2 times positive 11 is negative 22. Finally, since we want it in slope-intercept form as a final answer, solve it for y. Subtract 12 from both sides. Negative 22 divided by, minus 12. Negative 22 minus 12 is negative 34. So our slope-intercept form of the answer is negative 2x minus 34. Let's write an equation of the line through negative 4, 0 and 6, negative 1. We want to write the equation in standard form. So that's the form with the x and the y on the same side. Well, first we have to find the slope because all we're given is 2 points on the line. So take those 2 points and put them through the slope formula. M equals y2 minus y1 over x2 minus x1. Y2 is negative 1. Y1 is 0. Negative 1 minus 0 is negative 1. X2 is 6. X1 is negative 4. 6 minus negative 4 is 6 plus 4 is 10. So our slope is negative 1/10. Now we have the slope. We have 2 points. We only need 1. Let's plug in to point slope form. Y minus y1, y minus 0, equals m, negative 1/10, times x minus x1, x minus negative 4. We're using the point negative 4, 0. Remember, that was one of the points we were given, negative 4, 0. We would also get the same answer if we used 6, negative 1, though. I promise. Simplifying, y minus 0 is y, x minus negative 4 is x plus 4, and then we can multiply both sides by 10 to clear the fraction. Distribute that negative 1. We get 10y equals negative x minus 4. And be careful here. Don't divide both sides by 10. We wouldn't be going in the right direction. That would be undoing what we just did. Remember, this one wanted to be in standard form, the x and the y on the same side. So let's add x to both sides, and that'll get us into standard form. X plus 10y equals negative 4. Another one. Write the equation of the line graphed. Write the equation in standard form. Well, we need to identify 2 points on the line. And it doesn't look like the y-intercept is going to be one of those points because it doesn't cross on one of the grid points. But I see 1, 2, 3, 4 places that do cross the grid exactly. We only need 2 of them. So let's look at 2, 5, which is right here, and negative 4, 3, which is right here. Let's find the slope. And we use the slope formula. Plug in y2 and y1, subtract. Plug in x2 and x1, 2 and -4, subtract those. 5 minus 3 is 2. 2 minus -4 is 2 plus 4 is 6. And then 2/6 reduces to 1/3. Notice if we start over here at -4, 3, and we go up to right 1, 2, 3, 4, 5, 6, there's our other point. And remember I said I saw 4 places? 1/3, a rise of 1, a run of 1, 2, 3. We could have used this point. Up 1, right 1, 2, 3, up 1, right 1, 2, 3. We could have used this point. We also technically could have just started at one point and went up and over until we got to another one, and up 1, right 3 gets us to another point. So 1/3 must be the slope. Up 1 over 3, up 1 over 3 keeps getting us to points. We're not done though. We wanted to write the equation in standard form, and all we have right now is a slope. Well, and 2 points on the line. Let's use -4, 3 along with the slope. Put it in point slope form. Y minus y1, y minus 3 equals 1/3 times x minus -4. That gives us y minus 3 equals 1/3 times x plus 4, minus a negative is plus. And then we could multiply both sides by 3 to clear the fraction. So multiply by 3 on the left, multiply by 3 on the right. The 3 times the 1/3 cancel away. Distributing the 3 on the left, we get 3y minus 9. We're left with just the x plus 4 on the right. This needed to be in standard form, so subtract x from both sides, add 9 to both sides. We get -x plus 3y equals 13. 4 plus 9 gives us the 13. Now, sometimes we don't like equations that start with negatives. So we're also allowed to say that this is positive x minus 3y equals -13. Divide through by the negative so that it starts with a positive regular x as opposed to the opposite of x. A word problem. In 2007, Window World Incorporated had 50 employees. In 2022, the company had 85 employees. Let X represent the number of years after 2007, and let Y represent the number of employees. Let's assume that the relationship between years and number of employees is linear, and write an equation to describe this relationship. And then once we have an equation, let's use it to predict the number of employees in 2017. So X is the number of years after 2007. Y is the number of employees. So the very first sentence says in 2007, Window World Incorporated had 50 employees. X would be 0 because 2007 is 0 years after 2007. So X is 0. Y is the number of employees. Y is 50. So the first sentence gives us the point 0, 50. And then 2022, that's 15 years after 2007. So X would be 15. And the number of employees is 85. That would be Y. So 1585 is a second point. Now that we have 2 points, we can find the equation. Because 2 points can be used to find a slope. Y2 is 85, Y1 is 50, X2 is 15, X1 is 0. Subtract 85 minus 50, subtract 15 minus 0. We get 35 over 15, which reduces to 7/3 by dividing top and bottom by 5. So M equals 7/3. What's B? Well, B is the y-intercept. That's what happens when X is 0, and we have the point where X is 0. 0, 50. So Y equals 7/3 X plus 50 would be the equation in slope-intercept form. How else can we get the equation? We can start with point slope. We can substitute in values for M, X1, and Y1. Distribute the 7/3. Add the 50 to both sides, and there's the same equation. So if we didn't recognize that we already had the y-intercept, we can just keep going like normal, and we can end up with the y equals 7/3 x plus 50 anyway. So now we're supposed to use the equation that we just found to predict the number of employees in 2017. Let's go back to refresh. Y is the number of employees, X is the number of years after 2007. Back to the future. 2017 is 10 years after 2007. So X is 10. We plug 10 in for X. We get 70 over 3 plus 50. That's about 73. We have to go to the calculator to get 70 divided by 3 plus 50. But we'll get about 73. The fourth objective in this topic is write equations of vertical and horizontal lines. And our first example is to write the equation of a horizontal line containing the point 45. So you could go through the trouble of remembering which one is horizontal, which one is vertical. One of them is x equals, one of them is y equals. We know they don't have the other letter. It's just x equals a number or y equals a number. And the easiest way to remember it is the axis you strike is the letter you have. The axis you strike is the variable you have. So a horizontal line goes left to right. It would go right through the y-axis. So it's the y equals a number. Well, what is the y in the 0.45? The y equals 5. So the equation of the horizontal line containing that point must be y equals 5. Again, horizontal lines strike the y-axis, and the y equals 5. Write the equation of a line containing the point 4, 5 with an undefined slope. So think about what undefined slope was. Undefined slope was the up and down, was the vertical line. That strikes the x-axis, and here x equals 4. The fifth objective in this topic is finding equations of parallel and perpendicular lines. Write an equation of the line containing the point -2, 4 that's parallel to the line x plus 3y equals 6. Write the equation in slope-intercept form. Well, parallel lines have the same slope, so to be parallel to the line x plus 3y equals 6, we need to know the slope of the line x plus 3y equals 6. So let's put that line in slope-intercept form. Subtract x from both sides. That gives us 3y equals -x plus 6. Divide both sides by 3. That gives us -1/3 x plus 2. So we can see that the slope is -1/3. Parallel lines have the same slope, so we're going to use the slope of -1/3 for our new equation, along with the given point, -2, 4. So point slope form. Let's get rid of that fraction first. Multiply both sides by 3. Distribute the 3 on the left. Simplify on the right. -1 times x plus 2 would be -x minus 2 on the right. We want to be in slope-intercept form. So solve for y. Add 12 to both sides. -2 plus 12 is +10. 3y equals -x plus 10. Finally, divide both sides by 3. -1/3 x plus 10/3. Now, I would be remiss if I didn't mention that there is a shortcut, not really a shortcut, but since we need to be in slope-intercept form anyway, y equals mx plus b form, we can start with y equals mx plus b once we know what our slope is. Plug in -2 for x, plug in 4 for y, plug in -1/3 for m, solve for b, and then you have your m and your b. And you can just plug those into y equals mx plus b. You'd get the same equation. So more than one way to get there, but we're being consistent in our examples. We're going point slope form to either standard general form with the x and the y on the same side, no fractions, and if you really want to get technical, positive x's, or from point slope form to slope intercept form. Solved for y with the x on the other side, making the slope and the intercept plainly visible. Let's follow that process again with one more example. Write the equation of the line containing the point 3, -5 and perpendicular to the line 3x plus 2y equals 7. Write the equation in slope-intercept form. So we are starting with this line that we're given, 3x plus 2y equals 7. We want a line perpendicular to that, which means we need an opposite reciprocal slope. But before we can find the opposite reciprocal slope, we need to know what the slope of that line is. So solve for y. Subtract 3x from both sides. 2y equals negative 3x plus 7. Divide both sides by 2. Negative 3 halves x plus 7 halves equals y. Now we can see that this line has the slope negative 3 halves. Turn negative into positive and then flip the fraction. Positive 2/3 is going to be the slope we're going to use for our new equation. Positive 2/3, opposite reciprocal of the given slope. So we go to point slope. Y minus negative 5 is y plus 5. Let's multiply both sides by 3 and get rid of this fraction. So on the left, we have 3 times the quantity y plus 5. On the right, we're left with 2 times the quantity x minus 3. Distribute the 3 on the left, distribute the 2 on the right. 3y plus 15 equals 2x minus 6. We want slope-intercept form. We want to solve for y. So subtract 15 from both sides. Negative 6 minus 15 is negative 21. Divide both sides by 3, and we get y equals 2/3 x minus 7. And we found the equation that we want. And that is it for this topic. Horizontal, vertical, and my camera apparently is a little bit tilted, so let me see if I can make this horizontal line anymore. There we go, horizontal, flat. But we could also have diagonal lines, and diagonal lines can either go bottom to top, from left to right, or from left to right, they can go top to bottom. They can go up, they can go down. We read lines like we do English language words, left to right. Okay, if you're watching my hands, left to right. If you're watching my whole body, left to right. Okay, that was weird. Left to right. There we go. Follow the arrow. It's the 2 camera thing. The one facing me. Okay. It's important that we have these 4 different types of lines, and we describe each of these in terms of their slant, in terms of their slope. Something that rises from left to right, we say has a positive slope. Something that falls from left to right, we say has a negative slope. Something that is flat, you can imagine driving a car and it not being uphill or downhill, just being flat. We say that has 0 slope. And if something is straight up and down, maximum steepness, we say that that slope is undefined. And now we're going to talk about what slope is numerically and how to find it. And by the time we're done with that, each of these four names is going to make complete sense as to why we call this a positive slope, this a negative slope, this 0, and that undefined. Okay. Slope is considered rise over run. You may have heard rise over run before in relation to slope. But what does that mean? Well, rise is how much you go up or down. Run is how much you go left or right. Well, wait a minute. When we're graphing up and down, that's our y. That's our y-axis. And how much we go up or down from where we start to where we finish could be considered the change in y. And this Greek letter delta, this triangle, mathematically means change in. So how much we go up or down from one point to another, that would be our change in y. How much we go left or right, that's our x. So from one point to another, how much we go left or right would be the change in x. So if we have two y values and we want to find the change in them, the difference in them, we can take y2 minus y1, where our 2 points, our two x, y coordinates, our ordered pairs, are x1, y1, and x2, y2. To find the change in y, we would go y2 minus y1, and we would go x2 minus x1. And it doesn't really matter if we do one or the other. It's just it's important that whichever one we pick first, we do first for the y's and the x's. So you can do y1 minus y2, but if you did that, the bottom would have to be x1 minus x2. So either y1 minus y2 over x1 minus x2, or y2 minus y1 over x2 minus x1. And you're going to see the 2 minus 1 more often. But again, order doesn't matter as long as you keep them straight. And that's because who's to say that what I pick as my second point and as my first point aren't what you pick as your first and second? So the order is not going to matter as long as we're consistent. So this is what we call the slope formula. y2 minus y1 over x2 minus x1. And slope in math generally uses the letter m. So when we see m, that's going to mean slope. So let's find the slope of some lines that pass through some particular points using our slope formula. Let's start with the points -3, -2, and 2, 5. So if we call this x1, y1, and x2, y2, be careful. Don't get tripped up and go x1, x2, y1, y2. This isn't a point x and a point y. These are two coordinates. Coordinates have the form xy. So the first is always an x. The second is always a y. So y2 minus y1, 5 minus -2, x2 minus x1, 2 minus -3. It's important that we keep minus the negative because that's how we know that this is 5 plus 2 over 2 plus 3. This is +7 over +5. And we can't reduce that or simplify that any. So the slope of the line is 7/5. Now, what does that actually mean? That means that 7/5 is the rise over the run of this line. If we have a point, then to get another point, we would have to rise 1, 2, 3, 4, 5, 6, 7. And we would have to run 5. 1, 2, 3, 4, 5. And I probably should have done that from up here because a rise and then going back to the starting point, a run doesn't there we go. Doesn't do us much good. There we go. So if we went up 7 and right 5, we would get another point on the line. This is what a slope literally means. Points on the line are separated by a rise of 7 and a run of 5. Rise over run. Notice this is a positive 7/9. And what does our line look like? It rises from left to right. A positive slope. So a negative slope, one that falls from left to right, maybe it stands to reason that it's called a negative slope because we're going to get a negative m. Well, let's find out. Let's look at the points -5/2, 0. And 1, -7. Well, since the formula is not getting any harder, the only way I can make this more challenging is to throw in things like fractions. But we do it the same way. Here's an x1, y1, our x2, y2. We're going to do y2 minus y1 over x2 minus x1. By the way, to help you keep straight that x's are on the bottom and not on the top, think of this as a picnic table. When you have x's on the bottom of the fraction bar, you have a nice solid foundation, 4 legs, what you'd expect to see for a picnic table. A picnic table can't be held up by y's, it would topple over. So you want your x's on the bottom. y2 is -7 minus y1 is 0 over x2 is 1 minus x1, -5/2. -7 minus 0 is -7. 1 minus a negative is 1 plus 5/2. Let's go ahead and add these. 1 over 1, but we need to have a denominator of 2. So 1 is 2 over 2 plus 5 over 2. And we have that -7 on top. Call this a complex fraction, fractions with other fractions inside of it. Two plus 5 is 7. So this is -7 on the top and 7/2 on the bottom. -7 over 7/2 means -7 divided by 7/2. Dividing by a fraction is multiplying by the reciprocal. -14 divided by 7 is -2. Negative times positive gives us that negative. So all of that math just works out to -2. And if we plotted these points, and since I'm using the ruler for tick marks, you know there must be something important about the graph I'm going to draw. If we plotted -5/2, which by the way is -2.5, so an x of -2.5 and a y of 0 would be right there. An x of 1 and a y of -7 would be there. So this line looks like that. Negative slope falls from left to right. And actually, it falls a slope of -2. That's -2 over 1. So that negative can either go with the top, -2 over +1, or it can go with the bottom, positive 2 over negative 1. So this is either down to right 1, or it is up to left 1. The motions are the same either way, reflecting that the negative can either be with the top or the bottom of a fraction if we have a negative overall fraction. So from here, down to right 1 gets us back to the line. Down to right 1, down to right 1, or up to left 1, up to left 1. Down and right is the same as up and left. So negative numbers, negative slope, those fall from left to right. Positive numbers, positive slopes, those rise from left to right.